Welcome everyone, and thank you for taking the time out of your day to join us for our webinar on improved safety, minimizing property damage and downtime due to lithium-ion battery fires. My name is Christopher Winbun with Teledyne FLIR Sales Enablement Team. Joining me as presenter for this event, Dave Brissell, the Vice President of Business Development at MoviTHERM. Now, before we start, I have a quick service announcement that will assist you with engaging during the presentation. In the side kickout menu of your GoToWebinar console, you'll find access to the questions pane. This is your portal to ask questions during the event, so feel free to go ahead and do so if you have any questions or need clarification on anything related to today's event. At the end of this event, we will reserve time to answer questions live on the air. In the event we run short on time and don't get a chance to answer your question, we will follow up with you shortly after the conclusion of this event. So with that being said, I invite you to sit back, relax, as we are about to begin this presentation. Dave, over to you.
Chris, thank you so very much. And thank you to our attendees for your participation today. And thank you to FLIR for hosting this webinar. The agenda that we have prepared for you today for this webinar is as follows. First, we will provide a high-level overview of lithium-ion battery basics, and that includes the makeup of a lithium-ion battery and how lithium-ion batteries function. We'll follow that by describing the phenomena of thermal runaway, a common cause of lithium-ion battery fires. We'll then cover some infrared thermography basics, and we'll wrap up with how thermal imaging connected via the cloud can be a powerful tool in the early fire detection of lithium-ion battery fires. So with that, let's dive right in. A lithium-ion battery is an advanced battery technology that uses lithium ions as a key component of its electrochemistry. And there are several advantages to lithium-ion battery technology, and they include they have a very high voltage and charge storage per unit mass and unit volume. This results in a very lightweight and small battery package, producing lots of power and energy. Long run times compared to other battery types, fast charging capabilities which provide for less downtime for work and greater productivity. And they have what's called a very flat discharge curve. And this provides a very high constant power. So what that means to users is there's no sluggishness in equipment or tools or vehicles as the battery charge level decreases. Now, this is some interesting information. The lithium-ion battery market is huge and growing. In fact, the EV market, which is electric vehicle market, is alone predicted to rise to $93.1 billion by 2025. Bottom line, lithium-ion battery technology is not going away, and this subject or this content of monitoring this battery technology for potential fires to enhance safety and productivity is one that is growing in interest. So let's talk a little bit about, again, the anatomy of the battery. The lithium-ion battery cell is made up of several parts. And the cell, as illustrated here, is considered to be the workhorse of the battery. It is the most critical component of the entire battery. The cell is comprised of the following components. There are two electrodes which are located at the battery cell ends. One is an anode and the other is a cathode. Both the anode and the cathode electrodes store lithium. The anode is typically made from carbon and the cathode is made from a chemical compound that is a metal oxide. An electrolyte sits between the two electrodes. It allows for the transportation or the migration of the positively charged lithium ions from the anode to the cathode and vice versa, depending on whether the battery is charging or discharging. Within the electrolyte, there exists a micro-permeable separator. And it's this separator that allows for the migration or passing through of the lithium ions, which are very small, but it restricts the flow of the electrons, causing the electrons to transport through an outside circuit. This separator material plays an extremely critical role in the battery's overall performance and safety. The separator is very thin, it's porous, and it's an insulating material between the positive and negative electrodes, or the cathode and anode. And its main purposes are as follows. First of all, to prevent electrical short circuits. This separator acts as a physical barrier between the positive and negative electrodes, preventing any form of contact, direct contact between them. If these electrodes were allowed to touch, it would create a short circuit, and that would lead to very rapid and uncontrolled discharge of the battery, potentially causing overheating, fire, and explosion. That separator has insulative properties that help maintain the necessary electrical isolation between those electrodes. I've already mentioned this earlier, that the other purpose, or another purpose, of the separator is to allow for ion transport, and in this case, lithium ion transport. During charge and discharge, the lithium ions will move between the negative and positive electrodes through the electrolyte and through that separator. That separator allows for just the transport of those lithium ions, causing the negative electrons to pass through an outside circuit. Another purpose of this separator is safety. These lithium-ion batteries, as we'll talk about in more detail later, are extremely sensitive to temperature and voltage fluctuations. And if the battery experiences thermal runaway due to overcharging or over discharging or some form of external damage, which we'll talk about more detail later, the separator's heat resistance and insulation properties help mitigate that catastrophic failure. And finally, that separator has an impact on the battery's overall performance. So the selection of the material and its properties will most definitely impact the battery's overall performance. So again, that separator is a key component to the overall performance of the battery, and a key component to the safety of the battery. All right, as the name suggests, lithium-ion batteries are all about the movement of lithium ions. The ions move one way when the battery charges. That's when it's absorbing power. They move the opposite way when the battery discharges, when it's supplying power. During discharge, lithium ions, represented here by the red circles in the graphic, they will flow from the negative electrode, or the anode, to the positive electrode, the cathode. And they pass through the electrolyte through the separator. At the very same time, the electrons, which are unable to pass through the separator, they go through an outer circuit because they're just too large to pass through the separator. Those electrons, they'll pass through the device that we're powering and then back into the circuit, and they'll recombine, if you will, with the positive ions at the positive electrode, and there they'll deposit lithium. It's a side note, the electrical current flows from the positive terminal to the negative terminal, and it's opposite the flow of the electrons, and that's what's creating the voltage difference in power to our device. Now, when all of these lithium ions have returned to the positive cathode electrode, the battery will be fully discharged. There's no more lithium ions to travel or electrons to flow, so it will require charging. So let's look and see what it looks like, our cell that we have displayed here during the charging phase, or charging mode. During charging, the lithium ions will now flow from the positive electrode, which is the cathode, to the negative electrode, which is the anode, through the electrolyte and the separator. And again, at the same time, negative electrons flow from the positive to the negative electrode through the outside circuit. And then they recombine at the anode when the system is, again, fully charged. And once that has occurred, then the battery is ready for usage. Now let's move on and talk about, I've referenced this already, thermal runaway. What is this? Well, it is the primary phenomena or cause of lithium ion battery fires. And it occurs when the temperature of the lithium ion battery reaches a critical state such that the reaction rate of an exothermic reaction, which is a chemical reaction inside the battery, increases the temperature, which in turn leads to further acceleration of the reaction rate. And this causes a cycle of heat generation, temperature rise, increased reaction rate, which continues at to a point upon which there's ignition and potentially explosion. Now, what can initiate thermal runaway in a lithium-ion battery? There's essentially two forms of events. There's external causes, which will trigger thermal runaway, and there's internal causes that will trigger thermal runaway. Internal initiation events are mainly attributed to manufacturing defects that result in electrical shorts that generate heat. External events are associated with electrical abuse, which is essentially overcharging, discharging, mechanical abuse, which is actual physical damage to the battery, or thermal abuse, which is exposing the battery to extreme temperature conditions. So either external, through the events that I just described, or internal, which are the causes that result at the defects at the manufacturing stage, can cause this thermal runaway. What's most worrying about manufacturing defects is they're very hard to detect by just looking and inspecting a battery, and they can occur over time. So while a battery may appear to be fine at 100% at the time of manufacturing or put in use, at a later time it could degrade to such a stage that it results in thermal runaway. So let's drill in just a little deeper here into these events. All right, let's talk again first. Well, let's talk first about internal initiation. And as previously discussed, the lithium-ion battery operation is all about the movement of lithium ions. And again, that's shown here in this slide. I have ions moving in one direction during discharge and in another direction during charge. And if there's anything within that battery cell that impedes the flow of those lithium ions or the flow of electrons, or if there's anything internally that allows for the uncontrolled transportation or migration of these ions and electrons, that's when you can start to have problems. So what are some of the things in the manufacturing phase that can result in thermal runaway later? Well, those things include debris and contaminants that may end up on the electrodes or in the battery materials internally that go undetected. Those can create conductive pathways within the anode and cathode, leading to shorts, which again can lead to the generation of heat, which could lead to thermal runaway. Other points of potential manufacturing failure could be wrinkles in the separator. Again, that separator is designed to keep the cathode and anode, or the positive and negative electrodes, from making direct contact. And if the separator is damaged in any way, if there's a wrinkle or something that is actually reducing its insulative characteristics, that could lead to a short, again, which leads to heat, which leads to thermal runaway. You could have poor electrode alignment. So if the cathode and anode aren't properly aligned, again, any form of direct contact leads to a short, and then we have heat. Any kind of impurities in the electrolyte could result in unwanted chemical reactions. And again, when you have these reactions, you usually see the impact or result of heat being created or formed. Another form of manufacturing defect could be poor welds or tab connections. And anytime you have a poor weld or anything that, again, reduces the flow of current, results in heat. You can think of resistance in an electrical circuit. That resistance impedes the flow of current and creates heat. If you have too much electrolyte or there's imbalances, that can result in problems. And during the drying phase, when the electrodes are being created or coated with their materials, that can result in problems. You could have damaged current collectors, which sit at the very, very end of the battery cell. Again, anything that leads to either a resistance to the flow of these ions and electrons or a reduction or compromise to the control of that flow can result in some type of short, some type of increase in temperature, which could result in thermal runaway. And again, these things could happen over time. And so they may go unnoticed initially, but then present themselves later as the battery ages. Now, external events are much easier to view, much easier to see and to witness. And maybe easier to prevent. And there's different forms. For example, a mechanical event can occur when the battery is punctured or compressed. And this compression or this puncture, it could create, again, damage to the separator. It could result in the electrodes coming in contact with each other, the positive and negative, or cathode and anode. And again, having direct current is what results in that short. There's no restriction now to the flow of electrons or of the lithium ions. And so you see a very rapid increase in temperature. And that initiates the thermal runaway process, and next thing you know, you have combustion. This can occur when it's either compressed or punctured. Electrical abuse, I touched on just briefly, occurs when you have improper charging or even discharging of a battery, where if you're overcharging the battery with excessive voltage or current, this can cause the battery to overheat. And if that temperature reaches that critical point of that exothermic reaction, that just starts the process of thermal runaway. Making sure that batteries are being charged properly and discharged properly will ensure, guarantee, or prevent this thermal runaway process. Thermal abuse of a lithium-ion battery is pretty straightforward, and that's exposure to excessive heat. Again, if you start to create a rise in temperature and it reaches that point of that exothermic reaction rate, then it can take off and start running. So making sure that the batteries are stored or maintained in areas where they are not exposed to excessive heat or high temperatures like that. Now, manufacturer batteries, they design into their batteries, protective type measures or safety measures to prevent as best as possible any of these potential failure modes, but they're not 100%. And that leads to the need for a way to monitor these batteries and detect rises or increases in temperature at the earliest stages to mitigate and prevent a fire. So with that in mind, let's do a little infrared thermography review for those of you who are very familiar with it, and an introduction for those of you who are not. Infrared thermography is essentially this. It's utilizing a thermal camera or an infrared camera to assess an asset or a process, to ascertain the health of that asset or process by looking at it and by measuring it with an infrared camera. Thermography is all about utilizing a temperature calibrated camera, which we'll talk about briefly. In this slide here in the upper left, I have a graphic of the electromagnetic spectrum, and it represents all the different forms of light available in the universe. What's interesting to note is that our human eye, which is tuned to see the visible spectrum, really only sees a small sliver of the different forms of light available in the universe. Also interesting to note is that infrared light is a direct neighbor to visible light, with the only difference being the size of the wavelength. Infrared light having longer wavelengths. As such, our eyes, which are tuned to see visible light, we unfortunately cannot see that infrared light. Another keynote to make is that because the only difference between infrared light and visible light is the size of the wavelength, they behave very similarly. meaning infrared light, like visible light, can be focused, it can be reflected, it can be transmitted, it can be absorbed, it can be emitted. So they behave very similarly. Another key point to note is that all objects, materials above absolute zero, which is about minus 273 degrees C or 460 degrees Fahrenheit, emit infrared light. Even the coldest of objects above absolute zero emit some amount of heat. Now, unfortunately for us, the longer wavelengths of the infrared are undetectable by our eye, but fortunately for us, companies like FLIR have infrared detectors that are tuned to see infrared light, and when those detectors are integrated in a camera, they can present that light in a visible spectrum for us to view. Well, how do these infrared cameras work? Well, shown here in this slide is an infrared image of a lithium-ion battery being punctured with a drill. And so you see visibly this thermal runaway occurring. We see it qualitatively. So we see different colors that are representing different temperature values at this point. This grid that you see, the graphic that's overlaid, is a representation of the several thousand detector elements that make up this thermal image. There's actually many more. But these elements, or what are sometimes called pixels, allow us to measure, report, and see this infrared light. Now, there are some cameras that are calibrated, temperature calibrated, to report or present a temperature value. And if I happen to have a calibrated infrared camera pointed at my target like this, the lithium-ion battery being penetrated by a drill showing thermal runaway, I can apply measurement tools. These tools are referred to as regions of interest, and they could be spots, lines, areas, shown here. But I can apply these tools, and then I can start to extract temperature values and make measurements. It's pretty amazing technology. In this particular example here in this slide, we have a FLIR A70 camera. This is what's called an uncooled microbolometer camera, and it has a detector in it that's made up of several thousand detectors. It's actually a 640 by 480 array, which is more than 300,000 elements or pixels. And it's almost like having over 300,000 spot pyrometers pointed at my target to make measurement, but also create a qualitative representation or image that I can visibly see what's going on here. I can see where the heat is by just looking at this image. It's pretty amazing technology. So why does thermal imaging or infrared cameras work so well for early fire detection? I really like this chart here, which describes fire progression versus damage severity versus the different types of fire detectors, smoke detectors, heat detectors, and things like that. And from this chart, you can see right away that infrared cameras are represented at the very earliest of the fire progression. And that's because they see, if you will, hot spots. They see hot spots before the formation of smoke. They see hot spots before the formation of fire. So they see things at the earliest stages when damage severity is the lowest. And that's why they are such a valuable tool for early fire detection, because they detect at the earliest stages of ignition. What also makes these powerful instruments is that these cameras today, and these specifically shown here, they are what we call smart cameras. They have built-in intelligence that gives them on-edge detection capabilities. They're available in different price points and different resolutions and lens configurations to meet just about any monitoring application. And in addition to that, they use some of the latest communication protocols that make it so very easy for plug and play usage. All right, let's transition now and talk about applications for thermal imaging for early fire detection of lithium-ion batteries for safety, productivity, and health reasons. But before we do that, I just wanted to share with you an illustration of the battery life cycle, which starts from mining and refining to R&D and production, to storage and use, to recycling, and then eventually into the waste stream. I wanted to point out by just showing you this life cycle that infrared thermography is actually a valuable tool at each and every one of these stages of the life cycle. But for the webinar today, we're focusing primarily on these two areas, storage and use and waste. And that will make sense as we explore these applications. And here's a slide with a bunch of images showing different types of storage and usage type applications. And if anybody participating in this webinar has ever shipped anything, especially electronics, you should be very familiar with the potential fire hazards of lithium-ion batteries, because that's one of the questions on just about every shipping label form that is out there. Now, some of the different examples shown here include charging stations. Some of them show where batteries are being warehoused. One shows how batteries are being transported. Some are collecting energy that is being stored from solar panels that go to work essentially after the sun goes down. But I mean, lithium-ion batteries are everywhere, even in things like electric toothbrushes nowadays. Now, most recently, I thought it was interesting when I was traveling, I was actually asked by a flight attendant, and if you've been on an airplane lately, you've experienced this as well, where I was asked not to retrieve my phone if it happened to fall between my seat. Why on earth would they ask me for that? Well, the reason why is they want to make sure that we are avoiding any kind of mechanical abuse to a lithium-ion battery, which does reside in a phone. And if you're happening to be fidgeting around, or if it gets compressed in your seat, things get compacted, there's a puncture, that process of thermal runaway that we talked about earlier by mechanical abuse could technically occur. So perhaps you've experienced that most recently as well. All right, so let's talk about early fire detection for battery monitoring. And this is primarily for those storage and usage applications that I was sharing with you earlier. Typically what happens in this process is that there's an initiating event that causes a temperature rise in the device or in the battery, and that thermal runaway process starts. And especially when batteries are stored together or in close proximity to each other, what can happen is any heat generated from a single battery can actually cause an increase in temperature to adjacent batteries, which can start the thermal runaway process in those batteries, which can start heat flow in the batteries adjacent to them. So this, for like warehousing or storage or transport, can be a huge issue, even with just one battery cell initiating into runaway. So anything that can be done to mitigate or catch fires early to prevent the spread is critical. And early fire detection utilizing infrared cameras is one method for this application. Another interesting application that involves lithium-ion batteries is actually in the waste and recycling space, where we see more lithium-ion batteries in consumer goods than ever before. And when you combine that with this increased emphasis on recycling, we see more waste batteries, if you will, in the waste stream. These are ending up in transfer stations. They're ending up in recycling centers, even like metal recycling centers. And if any of those batteries are crushed or punctured during the recycling process, it can initiate a thermal runaway condition, which can result in a fire. Now, if this happens to go unnoticed by those who are responsible for material handling at that waste or recycling facility, they can inadvertently spread the fire unknowingly because they don't see it. They don't know it's there because they're sitting back in the heavy equipment running the bucket. This is another area that can benefit greatly by thermal imaging for early fire detection. All right, so that brings us to this point. Let's talk about what a solution looks like utilizing thermal imaging and cloud connectivity. Before I do that, I wanted to share with you our vision at MoviTHERM. And my hope is that when I start to talk about these solutions and share with you these solutions, you see this vision as part of those solutions, which is making hindsight irrelevant with smart thermography solutions that enhance awareness and simplify the complex. What we mean by making hindsight irrelevant is trying to help customers avoid the pain of making the mistake. If we can develop a solution with thermal imaging, smart thermal imaging, that helps customers, industry, manufacturers, recyclers, waste managers, you name it, avoid a mistake, that's our goal and objective. And we do it utilizing thermal imaging. The name MoviTHERM stands for Motion Vision Thermography. It's wrapping solutions around infrared. And we do that to enhance awareness and simplify things that could be considered to be complex. Okay, so now let's talk specifically about the solution. What does a thermal-based, infrared-based early fire detection solution look like? All right, and what does it include? Well, here's a schematic, and this is a kind of a graphical representation of the different components that could be part of a early fire detection solution. This happens to be an example of one that could be used for metal recycling. It has infrared cameras. It could also include visible cameras. Those cameras being connected through a gateway that talks to the cloud. Within that cloud resides a platform that is receiving this information from these different sensors, and through the software, creating the alerts, the alarms, the notifications, the controls that are necessary to mitigate fire, prevent fire. The different components include the IR cameras. That's a key ingredient here because, again, they see the heat before the formation of smoke and fire. Cloud-based connectivity allows us to take multiple cameras, multiple infrared cameras, and maybe even additional sensors like visible cameras. It could even be smoke detectors, heat sensors, but collect all of that sensor information and pull it together. By doing it this way, and utilizing the cloud to do that, we can minimize the hardware requirements dramatically. By integrating this to the industrial Internet of Things, we can create an event-based system that is very simple, yet increases awareness. Another key feature of this type of system is automation, meaning because software resides in the cloud, all updates are done automatically, and there's no conflicts between software that resides on a server versus software that's on a computer versus software that's on a smart device like a phone or a smart pad. It's all independent and things happen automatically. New features that are released and developed happens automatically. No installs, no conflicts. Customized notifications means you can set up dashboards and views and maps and alerts and notifications depending upon your very specific application, and I'll go into that in a little more detail. And then finally, being able to set output controls. Maybe you want more than just alerts or notifications going to someone via a smart device or their phone, but you actually want to turn something off, fire up an extinguishing system. That can all be built into this type of system as well. All right, as I mentioned earlier, key to this are the infrared cameras. And I've listed some of the FLIR smart cameras that MoviTHERM currently utilizes in its early fire detection platform. And we have these installed throughout the United States. From the AX camera to the A50, A70, A400, 500, A700, and FH Series R cameras. These are the best cameras on the market today for doing early fire detection. And they have those key ingredients that I mentioned earlier, which is they have the onboard intelligence giving you the on-edge capabilities for detection. They have the communication protocols necessary for easy plug and play. They are also available with different lens configurations and pixel resolutions depending upon the application or the target that is going to be monitored. But these are the cameras that you'll see utilized today in a cloud-based early fire detection solution for lithium-ion battery monitoring. In the graphic earlier, I referenced a gateway. This is another component that is important to the system. What this gateway does is it collects all of the sensor inputs and combines it together. and it creates a on-edge intelligence for local alarms and alerts. It also allows for easy remote command and control. So by connecting to this gateway, you can have access to any camera, any sensor to make adjustments or changes. It also creates a redundancy in case internet connection is lost. So if the internet goes down for whatever reason, your system is still running because you still have on-site alerts and alarms. And this also has to do with the capability of the cameras, which have on-board alerts and alarms. And again, as I mentioned earlier, because you can draw regions of interest on these images, which you can do on all those cameras that I've just shown, the output from those regions of interest is what ends up here in this intelligent gateway. Another key component to the system, of course, is the software. The software you can consider to be the backbone of the system, if you will. And some key considerations for software is to make sure that it's secure. Our system happens to be a cloud-based monitoring application. It can be for a single facility, or it can scale to cover multiple facilities. It does have customizable dashboards and map views. Not only does it give you the threshold alarms from the infrared cameras, but it also tells you the health of those. Are they running? Are they performing properly? So you also get health alerts of your sensors, cameras in this particular example. Our software also has the capability to send email, text, and voice notifications. And it also allows for remote access from anywhere in the world at any time with an internet connection from any device. Now, our software also has the ability to be installed on site or in situ. So if you must have an on-site installation, our software can also be installed on site by having a local server. What are maps and views? Well, this is one key feature that our customers love about the MoviTHERM early fire detection solution. The view capability within the software allows you to create an overlay with your cameras and sensors. And you can use schematics of your facility or even photos of your facility from like a Google overhead or Google Maps view. On the left hand here is an example of an industrial biomass power plant facility. And the green check marks in the view indicate that all the cameras are measuring properly, and you can even see thermal images and visible images from those cameras in this view. The image on the right side is a different type of view. This is actually a schematic of an industrial laundry. And in this view, you see the green check marks, which is good. It indicates that all the cameras are running. There's no alarms. You also see the different camera icons, what they're looking at. There's even some heat sensors here. And you see those heat sensors displayed with their temperature outputs. The nice thing about these views is you can quickly identify any alarm and the location. Also, a key aspect of these views, and even the dashboards, is that they're shareable. You could create a shareable link and text or email that to someone. And if they click on that link, they'll see this view. They have no access to the software. They can't go in and make any changes or change any configuration, but they see this. Consider how this might be valuable if you were to share a link, let's say of the view on the left or even on the right, to a first responder who is headed to your facility to put out a fire or to help mitigate a fire. That first responder would receive that link telling them that there's a fire condition, an alert, an alarm. They would hit that link and they would visibly see the alarm and the location of the alarm. So even before arriving on site, that first responder would already start to be formulating a strategy on how to fight the fire, if you will, by having that shareable view. Another key point to our cloud-based solution is cybersecurity. It is based on Amazon Web Services and has 2048-bit encryption. Some customers prefer to have a cloud-based solution that is completely off network. And in those situations, we can even deploy a cellular-based connectivity that resides in the gateway. So you can bypass internal network completely separate, no chance of any kind of hacking or break-in. And as mentioned earlier, if a customer still wants to have that local deployment option, it is available as well. But it does add to it additional hardware, which can add to the complexity of the system. And it also introduces the need for updates and things like that. All right, alerts and notifications, this is huge because this is how you get the word out when an alarm condition is met, either because of system health or because of a measurement threshold. The options include email, text, and voice, and they're very easily programmed within the software. The text messaging, you simply type in the text that you want to send. If you want to include a link to a shareable view or dashboard, you include that and it's ready to go. And you set the threshold condition. The voice is a text to voice. So in the software, you enter in the text that you want to be essentially verbalized in the phone call. And that's what goes out. And email, of course, is very simple. There's an example shown here. These alerts are fully customizable. These notifications are fully customizable. They can also be tiered. So you can have certain notifications. As an example, at that biomass facility, let's say we want to have a low threshold alert to just notify the individual responsible for the fuel yard to go out and check. So at a very low temperature level, let's say 200 degrees Fahrenheit, someone gets an alert, go out and inspect this, make sure everything's okay. But then let's say we hit a threshold of 300 degrees. That could alert someone else within the facility. Let's say we hit something towards 400 degrees. That could alert the local fire department or first responders. And you can set all this up, tiered notifications, scheduled notifications based upon work schedules. You may have night shift, swing shift, day shift. Those can all be set up as well. All right, system access. I touched on this earlier. With our system, as long as you have a smart device, you can access it from anywhere in the world at any time. You can view dashboards, maps, imagery, sensor trends, the alarms. If you have the appropriate admin credentials, you can make adjustments as well from anywhere. So you're not having to log into a VPN or utilize a special device or come on site to do any type of programming or changing. You can do that from anywhere. And that is all viewed, whether you're on a tablet, on a computer, or even on a phone. You can view those dashboards, maps, and things, and you can make those changes as well from those devices. To kind of sum things up, when it comes to cloud-based thermal imaging early fire detection, I mean, the benefits are, first of all, you get the earliest detection of hotspots, fire progression utilizing thermal imaging. If it's cloud-based, there's less hardware and maintenance costs because there's no computer to maintain. There's no software conflicts to deal with. The IT burden is extremely low, if any. As I mentioned, no software to install, access from anywhere, and you can even assess the health of the system. So are my cameras operating properly? If I have smoke detectors installed, are they operating properly? Or heat sensors? Some heat sensors run on battery for like 5 years, but you can monitor that battery health through this system. All right. To wrap up, I'd like to share with you a video testimonial. And this happens to be from one of MoviTHERM and FLIR's customers. This is a biomass facility, and they're monitoring hog fuel piles, which is essentially a waste wood product that is in piles that ends up being put in the boiler to generate heat, steam, turn a turbine, and create power. And this is actually an interview with the local fire marshal.
My name is John Patterson, and I'm the Division Chief of Risk Reduction for Jackson County Fire District 3 and the Fire Marshal. We've had a number of big fires here at the fuel pile. It's one of those things that happens in situations like this when you pile up a bunch of combustible materials and it generates heat. So over the years, we've worked really close with biomass to come up with solutions to help prevent those fires. And so they brought this forward and we looked at it and we thought this was a fantastic idea. Being very familiar with infrared technology and how to use it and implement it for finding heat, taking action against that heat, and then evaluating the effects of that action are game changers for us. We use infrared all the time. I mean, we're in smoky environments with heat that we're trying to find when we can't see. So we know that the infrared is very valuable and very handy. Being familiar with that and knowing how effective it is, it was simple for us to support what biomass wanted to implement here. Once we understood the whole program and how they wanted to roll it out, it was a no-brainer for us. The advantages of using infrared for early fire detection gives us the opportunity to monitor the whole situation. And then we can historically monitor individual areas or spots so we can watch them develop over time. And the interesting thing is that when we take a mitigation action on the hotspot with the infrared, we can know in real time how effective we're being. Believe it or not, we have a couple of concerned business owners that have our direct cell phone numbers, and when they see things happening on the pile, they call us because they're concerned. Their businesses have been disrupted or damaged because of fires. So one of the things that has been very advantageous on our end is to convey this information to the neighbors and the concerned citizens and our board members, the actions and activities that biomass continues to take to make this safer for the community. The early detection and the infrared is just that next step in the evolution to keep the pile monitored and as safe as possible.
All right. Thank you again for your time. And Chris, I'll hand it back off to you.
Hey, thanks, Dave, and thanks for that extensive overview of lithium-ion batteries and early fire detection solutions that support that. And we have a mountain of questions here, folks. Listen, I know we're not going to be able to get through all these, but don't worry. If you have a question in here, we'll make sure that we follow up with you after the webinar. I'm going to go ahead. I'm going to get these going here for you, Dave. One of the first questions that we have in the question queue is, can you connect other sensors to the software?
You can, Chris. In fact, especially for early fire detection, other sensors that we found to be effective are smoke detectors, heat sensors. We have used visible cameras as well. And you know, keeping in mind that sometimes my line of sight to the target that I want to monitor may be you know, prohibitive. So I may need to use a different sensing technology in order to make sure that I have the coverage that I need for detection. Outside of early fire detection, just about any kind of sensing technology, you know, like voltage and amperage, it could be humidity, it could be, you know, even occupation. Any type of sensing technology can be incorporated into this platform. Also things like vibration sensors and things like that. So there's a standard out there. I think it was in one of the slides, the LORA standard. Typically, if you have a sensor that has that or meets that standard, it's easily adoptable into the platform. Hopefully that answers the question.
Awesome. Thanks, Dave. All right, next question that we have here is a question about licensing. How many user licenses come with the MoviTHERM software package?
Oh, another great question. So when someone subscribes to the platform, they have unlimited licensing. So it's very easy to extend access to the system to the number of employees that you have, or perhaps even individuals who are outside of your own organization, much like what the video that we just watched, that testimony there from the fire marshal. They actually have access to the system, the Biomass One system, and are able to view dashboards and trends and alerts and alarms. So it's unlimited. As long as you're, you know, subscribed to the platform, doesn't matter, as many as you want.
Excellent, excellent. We have a question in regards to the, are there any limitations to the number of infrared cameras that can be part of the early fire detection system?
No, not really. You know, we can scale this thing as large as it needs to be. So there is no limitation in that regard. Whatever is necessary to do the coverage that you need, it can scale.
Excellent, excellent. And are there any limitations of the infrared cameras for early fire detection monitoring themselves?
Oh, that's, well, another good question. I kind of touched on this a little bit. Again, it's line of sight. So you need to be able to see the area, the asset, the target of interest, if you will, in order to monitor it. So, you know, when we're working with customers, we're making sure that we're asking, you know, the right questions and leading and guiding customers along the way. And I think this is even covered in our guidebook that we have available on this subject. And that is, do you have the adequate distance to the target? Do you have enough pixels on target? Can you see the target? And if not, can we use some other type of supplementary sensing to add to and complement the system? So again, it's primarily line of sight. And there's some other parameters as well that we need to consider when it comes to infrared thermography, things like emissivity, reflectivity, and things like that. But hey, MoviTHERM's been doing this for 20 years plus, so that's why we have that expertise that we can ask those appropriate questions. Last thing we want to do is install a camera and not have it be effective in monitoring.
Excellent, excellent. Dave, I know you touched on being able to send alerts. We do have a question that's a little bit more focused. And this question is about, can we actually send the signal to the local fire station?
You can, and that's where the unlimited licensing comes into effect and can be helpful. But when you get into setting up the notifications and alerts, you can send those directly to, if it is a local fire agency, absolutely, that can be done. Again, kind of going back to the testimonial that we just watched, even though we were talking about biomass, the application there and how they're executing their program can translate very easily to lithium-ion battery monitoring. And if you want to, let's say, have a tiered alert or notification program, you could set up, let's say, at a certain threshold, maybe it's tier 3, you call it. At tier 1, it's all internal, and we're just sending someone to go check things out internally. Tier 2, it's the next level, a higher alert, and then maybe tier 3 would be, you know, red alert, we need to notify the fire department and get them on their way here. It can easily be done. So the answer to that is yes, you can send that to a local fire department or fire agency.
Perfect, perfect. We have another question in regards to a specific country, and the ask is this solution available in Germany, or will it be available in the near future?
So the answer to that question is yes. In fact, we're actually working with a partner right now and a customer that is in Germany. So the answer to that is yes.
Awesome, awesome. Okay, the next question we have is referring to the gateway. Can we connect it? Can we connect to it, right? Even, let's see, even a PLC or an IO device?
Yes, the answer to that is yes. So, and it's covered in the presentation. We didn't dive into it too much, but if you want to integrate some type of automated controls locally, you want to shut something down, you want to turn something on, you want to you know, initiate you know, an extinguishing system, you can do all that. So the answer is yes, you can tie it to a PLC, you can tie it to some type of IO device. So the system can do that.
Excellent, excellent, Dave. Hey, listen, we have a few more questions. Are there a couple in the question queue that you'd like to cherry pick to answer real quick?
Oh my gosh.
Like there's some quite extensive questions being asked that may need just a couple minutes for you to look at there.
Okay,
But,
no problem. Let's see, I see something here about the presentation being made available. I think that's a yes, right?
Absolutely. I'm sure we'll be able to take care of that as customary. Whenever we complete one of these events, we always make sure that the recorded presentation is available. So there will be some notification that will go out shortly after the conclusion of this event.
Yeah, I do see a question here about video connections. I guess that would be with the display to see what the camera is actually doing. And we touched on this a little bit about this in the presentation. And at least with the MoviTHERM system, the IEFD system that we're talking about here, all it requires is a smart device. And that device could be a smartphone, it could be a computer, it could be like a pad device. But that's all that is required to actually see what's going on. And we didn't do a demonstration of the system itself. And I would encourage anybody, if you want to see a virtual demo of the system, please, you can reach out and contact us. We have that ability. But you can drill into very specific cameras in your monitoring system. You have the ability to look at things historically from an imaging perspective, as well as the temperature data. So these cameras have, the ability to measure temperature, and we actually capture that over time and create trends so you can kind of see how things have been performing. I saw a question about that. So just a smart device, and you can see imagery, and then you can also see the quantitative information or the temperature information as well.
Awesome. Awesome. Thanks, Dave. Folks, we're coming up right close to the top of the hour, and I do know that there's a few pending questions still in the question pane. We'll make sure we follow up those with you shortly after the conclusion of the webinar. But before I let you all go, I'd just like to quickly point out two things. There are some handouts in the GoToWebinar Council. You can take those with you if you didn't already see them, so that if you need any additional information on the technology or the actual batteries, that information is readily available within the council. We also have a quick survey at the end of the webinar. So as soon as the GoToWebinar closes out, when we complete the session for today, we're just asking for a couple seconds of your time. If you wouldn't mind just filling that out for us, that would be great. Dave, thank you for your time today. Great presentation. Everybody, thank you for your time for joining today. It was a pleasure having you here, and enjoy the rest of your day.